This lesson video will have two main purposes. First, it will help you properly symbolize sentences of English into meaningful statements in truth functional logic. And then, with a better understanding of how sentences in truth functional logic are constructed, you'll be better prepared to eventually analyze statements of truth functional logic so you can later evaluate their logical roles in arguments. Part of this lesson is going to be important for symbolizing English sentences, and part of it will be important later when we come to analyzing arguments. Our main goals in this video are to construct and recognize complex, well-formed sentences of truth functional logic that use the logical connectives we've just learned. You should also be able to identify the scope of logical connectives and to identify the main connective in a sentence of truth functional logic. A sentence of truth functional logic is an acceptable and meaningful combination of the symbols of truth functional logic. So when we symbolize sentences of English, we want to symbolize them with sentences of TFL. All of the sentences of TFL that we use to symbolize sentences of English can be built up from a small set of symbols, all of which should already be familiar. So the ones we've looked at have been simple sentence letters like A, B, and C. Remember, these should be capitalized and italicized. And we can also, for simple sentence letters, if we need more than we have letters of the alphabet, we can use ones with subscripts. So that'd be like A sub 1, B sub 1. We'll try to avoid doing that when possible. We also looked at conjunction, negation, disjunction, and the conditional and biconditional. And we use parentheses to mark the boundaries of each of those connectives. What we see on this page are the rules that describe what is a well-formed sentence in TFL. Any symbolization of a sentence of English into TFL must be constructed in a way that obeys these rules. Any other combination of symbols is just nonsense. So here are the rules. First, basic sentences of TFL are atomic statements. So, rule 1, every sentence letter is a sentence of TFL. Those are the simplest building blocks we use to construct sentences. Then we can build more complex statements in TFL from sentence letters and logical connectives. Notice here, though, that we're not using the sentence letters to describe the rules. We're using these curly A's and B's. And we'll talk in a minute about why they mean something a little different. But the important thing is that they can stand for any sentence of TFL. So the rules for constructing sentences are if A is a sentence, then not in front of A is a sentence. If A and B are sentences, then A conjunction symbol B is a sentence. If A and B are sentences, then A disjunction symbol B is a sentence. If A and B are sentences, then A conditional symbol B is a sentence. And if A and B are sentences, then A biconditional B is a sentence. The last rule is that nothing else is a sentence. So these 6 rules, plus nothing else is a sentence, tell us any way we can build a meaningful statement in truth functional logic, a way to convey a meaningful statement of English with these logical symbols. In the rules we just looked at, the curly letters A and B are metalinguistic variables. They can be replaced by any kind of sentence of truth functional logic. So metalinguistic variables aren't just sentence letters. They can't be used to symbolize sentences of English. Instead, their purpose is that we can use them to describe the logic. So in this case, they're variables that can be substituted with sentences of truth functional logic. So here's how we would use this rule in a concrete example. The rule is if A and B are sentences, then A conjunction B is a sentence. So we can replace A and B with a sentence of the logic of any degree of complexity. So we could replace A, that curly A, with not A, and we could replace curly B with R, and we would get a sentence. Not A and R. All of that in parentheses according to our rules of conjunction. But we could also replace curly A and curly B with slightly more complex sentences. A then B, and not C or D. That allows us to construct with this same rule the complex sentence, if A then B, and not C or D. Note that the parentheses mark the boundaries of each connective. So any combination of symbols in truth functional logic built up from those rules for what counts as a sentence will itself be a sentence. So for example, we can follow those rules to build up this complex statement, P and the negation of P and not C. So we start with our atomic statements. Those we know are sentences, P and C. We can add, according to our first rule for complex sentences, we can add a negation to get not C. And then we can make the conjunction of any two sentences. So we can conjoin the sentences P and not C. That's the fourth line. And then we can take the negation of any sentence. So the fifth line is the negation of P and not C. And then we can conjoin something to that sentence. So in line 6, we get the conjunction of P and the negation of P and not C. Each of those steps is itself a well-formed formula that's a constituent of the sentences below it. Let's contrast sentences of truth functional logic with expressions that use the symbols but are not sentences. They're nonsense. So the following are sentences, P and C, the negation of if P then C, P or P and Q, if P then not C, P and the negation of if P then not C. The following are not sentences of truth functional logic. P, biconditional. There's nothing on the other side of the biconditional, so it's not a sentence. The negation of P or, no closed parentheses, nothing on the other side of the disjunction, not a sentence. Negation or if Q then P. The negation doesn't apply to anything and there's no first disjunct, so again, not a sentence. So if you refer to the rules, they'll guide you to the fact that none of those bottom three combinations of symbols can be constructed using those rules. I want to take a moment to look at parentheses again in a little more detail because they'll help us understand another important concept. We've already seen a hint as to how parentheses are important in properly symbolizing sentences of English. We saw that how we combine the following two atomic statements with conjunction and negation can impact the meaning of the whole sentence. So if we have the atomic sentences P for Shelley ate peas and C, Shelley ate the carrots, we can either get the negation of P and C, so notice where the parentheses are with respect to the negation and the conjunction. That one meant Shelley didn't eat the peas and the carrots. So she might have eaten one or the other, but she definitely didn't eat both. Whereas if we have not P and C, note here that the negation applies just to the letter P, that means that Shelley didn't eat the peas and she ate the carrots. The role of parentheses then is to indicate the scope of logical connectives. The scope of a connective is the sentence or sentences it applies to. So a negation will only apply to a sentence. A conjunction, for example, applies to exactly two sentences. The scope of a connective is going to be the smallest sentence of which it is a part. So let's talk about this example that we've looked at. The scope of conjunction in the sentence not P and C is just P and C. So the negation there is not in the scope of the conjunction. The scope of conjunction in that second example we looked at, not P and C, is the whole sentence. So the negation is part of the sentence not P, and it's one of the two conjoined sentences. So there, the negation is in the scope of the conjunction. Pause to see if you can figure out the scope of the stated connectives in this complex sentence. So for negation, it must apply to a whole sentence. And the whole sentence that it applies to is this conjunction, M and N. We can see that because it falls outside the parentheses of that conjunction, but it falls within the parentheses of the second conjunction. So it doesn't apply to that whole of the broader conjunction, just M and N. The scope of the second conjunction symbol, though, is the whole sentence. So it conjoins two complex sentences. It conjoins the negation of a conjunction and the double negation of an atomic statement. Note that when you write the scope of a statement, you write the connective and everything that it applies to. So for example, if you're writing what negation applies to, you write the negation as well as the statement it applies to. So we've talked about describing what the scope of an individual connective is, and we can also talk in terms of relative scope. One connective takes narrower scope than another if it is added earlier in constructing the sentence, according to our rules. So not M and N can be constructed only once we've written the conjunction M and N. You can only take the negation once you've got the conjunction. So that first conjunction symbol takes narrower scope than the first negation. A connective takes wider scope than another if it is added later in constructing the sentence according to our rules. With the double negation of L, the left negation can only be added once we have not L already. So the left one takes wider scope than the right one. Finally, one of the most important notions is that of the main connective. That's the logical connective that takes widest scope, and it's the one that's added last in constructing a sentence. So in this example we've been looking at, the second conjunction symbol can only be introduced once we've already constructed the two complex conjuncts, the negation of M and N, and the double negation of L. No other connective is added after, so that second conjunction is the main connective. Again, try pausing to test your understanding of relative scope. So, in this complex sentence, P or Q and the negation of Q and not R, we're going to look at the first conjunction symbol and the second conjunction symbol and determine which one takes wider scope. So the first conjunction symbol links P or Q and the negation of Q and not R. And the second conjunction symbol links Q and not R. Well, since Q and not R is a component of the first conjunction, that means it takes narrower scope. It has to be added first before we can add the first conjunction. So you have to construct Q and not R in order for not Q and not R to be one of the conjuncts of the first conjunction symbol. So the first conjunction takes widest scope. If we're constructing that sentence, it will be added later. And in fact, it's the connective that is added last. The first conjunction is the main connective. To see that it's the main connective, think about how you would build up this complex statement, starting with the atomic sentences P, Q, and R. That first conjunction would be the connective added last, so it's the main connective. And with that, you now have all the tools to construct complex symbolizations of sentences in English. And in the last video in this lesson, we'll look at a few complications we sometimes have to consider when we try to capture the meaning and form of English statements with logical symbolizations.